Hi guys, I'm just going to give the solutions for number 3 and 4 from homework number 3. They were optional questions, but I've had some requests. People want some extra practice, a little bit more guidance. So they're a little bit more challenging than some of the questions I've given before. Obviously, you should be pausing the video and working on it on your own whenever you can, and then going back and looking at it. So let's start with number 3. We've got a systems of equations. And they're both already lined up nicely. So we've got the coefficients of x lined up, and the coefficients of y lined up, and the constants are lined up. So everything's ready for start. And this is a question where if we use substitution, it would not probably be the best idea, because if we isolate any variable there, we're going to end up with a bunch of fractions. So the reason that we want to eliminate is so that we end up with one variable, always the case. Now, we've already discussed on the purpose of that and why it works. Now, if we look at it right now, if we were to add these equations together, we would still have two different variables. So for example, if I added them together, I would have negative 5x, and I'd have 3y, and then we would have 9 plus 12. Okay, so it would be 21. Still two variables. So what we need to do is we need to manipulate one or possibly both of the equations so that we end up having a variable that will cancel out if we add or subtract. Now, if we look at x's, okay, if I double here and multiply everything in this equation by 2, we'll end up with 10x, and then if we add them together, they'll nicely cancel. Likewise, we could also cancel out the y's by doing the same thing, okay? Which is kind of interesting. So let's go ahead and do that. So I times everything in this equation by 2, and it's going to be equivalent, because if we multiply one side by 2 and the other side by 2, it's also going to be equivalent. So going ahead and write down the systems, we have 10x minus 6y equals 18. And here we're going to have negative 10x plus 6y equals 12. Now when we go ahead and add these together, negative 10x and 10x, we add them together, we're going to end up with 0. Negative 6y and 6y, we add them together, we also end up with 0. And when we add up here, we end up with 30. So we end up with something that says 0 is equal to 30. How can that be? How could we have, well, this clearly is not true. Okay? And there's no value that we can substitute that would satisfy both equations. If we were to go and graph this, we would see that, well, we would have two parallel lines. When we graph, we saw that before, there's no intersection, so there is no solution to the system. So in this case, this is a special case, we'll say there are no solutions. No solution. Okay? That's a special case. If you come across a question, a system of equations where you end up with something that cancels out, where you have, for example, 3 equals 3, or you end up with x is equal to x, or 0 equals 0, this is also another special case. In this situation, you would say that there are infinitely many solutions, and that's where we would have the identical, the same line. You might recognize that when you see the system with the two equations. You can see that they're identical. Let's look at the second question that I wanted to go over. So you guys can pause that. Go write that down. Number 4. Let me break this down. It had a system of equations with some fraction coefficients. So 2/3 x plus 1/4 y equals 5. And we had 5/9 x plus 1/2 y is equal to 3. That doesn't look too nice. But what do we do when we're solving an equation that has fractions in it? Think about that. let's get rid of the fractions. We know that if we multiply each side of the equation by a constant, that it will still be equal. So what can I multiply both sides by that will cancel out these fractions with a denominator of 3 and a denominator of 4? So if I multiply by 3, it'll cancel this fraction, but it won't work here. But if I multiply by 12, so if I multiply everything by 12, that will cancel out the fractions there. And while we're at it, let's do the same thing here. So to cancel the fractions here, we have denominators of 9 and 2. The lowest common multiple of 9 and 2 is 18. Okay? Now just to make matters a little more simple before we distribute, let's cross simplify. So 12 divided by 3, okay, that's going to cancel, right? So we're going to have, that will become 4, right? So 4 times 2 is 8x. And 12 divided by 4 is going to be 3. So 3 times 1 would be 3y is equal to, nothing is going to cancel here, so it's equal to 60. Okay. Multiply by 18. 18 divided by 9 is 2, so 2 times 5 is 10x. And 18 divided by 2 is 9. 9 times 1 is 9y. And 18 times 3 is 30, and 24 is 44. Or, sorry, 54. Okay, now it's a little bit more manageable. But if I look here, if I add or subtract, I'm not going to be able to get rid of the variables. I'm going to have to manipulate. Notice 9y and 3y. It would be easy to make this become 9y. And if I did that, then I could subtract one equation from the other, and I would have one of the variables eliminated. So how am I going to make this 9y? I'm going to multiply everything in this equation by 3. So I'll rewrite the system of equations below. So we'll have 24x plus 9y is equal to 180. And we'll just leave this one. So 10x plus 9y is equal to 54. Now, we can see that if we subtract one equation from the other, we're going to end up eliminating one of the variables. So we'll subtract this equation from the first equation. So 24x minus 10x is going to leave us with 14x. And 9y minus 9y is 0. 180 minus 54 is 126. Okay? So if we divide by 14, okay, so let's think about that. Mental math. How many times does 14 go into 126? It's going to be less than 10. Okay? So how about 9? 90 and 36. So it is 9. So x is 9. Okay? So we've got part of the solution here. But we need to find out what y is. So we could go back to the original equation, in which case we have a lot of fractions. Don't want to deal with that. So it doesn't really matter. We can pick an equation, for example here, and solve. So 10 times x, and now we know that x is 9, plus 9y is equal to 54. So 90 plus 9y equals 54. I'm going to subtract. So 9y is equal to, when we subtract 90, okay, so it's 36, well, negative 36 if we subtract 90 from both sides. Subtract 90 here and here. So y is equal to, we divide by negative 9 to both sides, negative 4. So the solution set, which is an intersection if we were to graph it, is